Okay, thanks for watching for exponential growth homework assignment. And so we already started off number 1 in class, and it was exponential growth, with a y-intercept at, if you plug in a 0 for x, that'll give you the y-intercept. And so that gives us y equals 2 to the 0 is just 1. So over 0, up 1 is where that is, right there. And so you want to make sure to, when you're doing these, you want to make sure to identify the y-intercept, to graph it, and then state if it's growth or decay or neither, negative growth. And then number 4, to list the horizontal asymptote. So make sure you do that for each one of these. And by graphing using your calculator or just doing an XY table. So number 2, using an XY table here, always start with 0 to find the y-intercept. So if we plug in a 0 there, we get 5 to the 0 power, which anything to the 0 power is just 1. And you'll see on your calculator there, 5 to the caret symbol, 0. So 5 to the 0 power is just 1. Okay, so that'd be over 0, up 1. So first we'll graph and identify our intercept there. Then we'll just choose a point to the left and to the right. So for example, like 1 to the right and negative 1 to the left. And so if we do that, we get 5 to the first power, which is just 5. So over 1, up 1, 2, 3, 4, 5. And then a negative 1 would be 5 to the negative 1. And 5 to the negative 1 can be written as just 1 over 5 to the positive 1. So take the negative power, make it positive, and put it down below in the fraction. Just to prove that, 5 to the negative 1 is 0.2, which as a fraction is just 1/5. So that means we'd go left negative 1 and up 1/5 would be very close to the x-axis there. And so our graph will go along and then exponentially take off upwards. So do arrows going both ways. The domain is all real numbers. The range is 0 to infinity, but we're not asking you to do that, but just know that. And then the horizontal asymptote is at y equals 0, is where it never crosses there. And so y equals 0 is the correct answer. And exponential growth is what's going on here. Okay, so those ones aren't too bad. You'll notice, let's see, maybe if we do a negative one, that might change things up a little bit there. So take a look at number 3. If we do an XY table with 0, we get negative 2 to the 0 power. And so negative 2 to the 0 power, well 2 to the 0 power is just 1, so it'll just be negative, so it'll be a negative 1 down here. And then 1 to the left, a negative 1, would be negative 2 to the negative 1. And so that would be negative 1/2. So negative 1, negative 1/2 is right about there. And then positive 1 would be negative, so it'd be negative 2 to the positive 1, which is just over 1 down 2. And so you'll see this one actually, put a 2 in there. Negative 2 to the 2 would be negative 4. So this one exponentially grows pretty fast, going in the down direction, right? Yeah, it goes down. Now you can use your calculator to make sure you're doing these right, which is always a good idea. So go to your calculator, go to y equals. We'll put in negative 2x instead of what we did, which was negative 3x on the guided notes, but here's negative 2x now. And so there we go. I don't think the negative, it depends on your calculator if that matters or not. But it should be down like that. And if you push trace, you'll see our y-intercept, which is worth points on the homework. And so that's at 0, negative 1. So it is going downwards. There is a y-intercept at, there is a horizontal asymptote at y equals 0. You can see negative 0.04, negative 0.03, negative 0.02, negative 0.01, negative 0.008, 007. So definitely approaching 0 there. So horizontal asymptote is 0. Now this is neither actually. This is called negative growth. because it is growing really fast but negatively. So neither, or you can put negative growth would be the correct answer there for number 3. So there's our asymptote at y equals 0. There's our 0, -1, which is our intercept. There's our graph, and it's neither negative growth. Okay, let's see here. Maybe do a tricky fraction one. It's not too bad, but might need to do some decimal stuff there. We'll try number 6, for example. So we'll plug in a 0, and we get 5 halves to the 0 power, still just 1. Y-intercept there. Then we'll put in a positive 1, and then we'll get 5 halves to the first power, which is just 5 halves, which is just 2.5. So over 1 up to 0.5. Put a negative 1 in, and that's going to flip it, actually. So we're actually going to get 2/5, which is smaller, which is not even half, and so that'll come here. If you want to use your calculator to make sure that you graph it correctly, you can go ahead and go to y equals and put in parenthesis 5 divided by 2 to the caret symbol x power, exponential symbol x power. So then we'll push graph, and so it looks like we are graphing it correctly there, which is great. And so we'll follow that along there. It looks like it does have a horizontal asymptote at y equals 0 again. This graph represents growth. So that one wasn't too bad. So where do we have a horizontal asymptote that's not 0? Well, when we have a number next to the function, for example, number 8 or number 7. So number 8 is going to have a horizontal asymptote at -2. And the reason why is because 5 to the x power, right arrow, brings it back down, -2. So that's going to shift it down 2. It takes 5x and it shifts it down 2. And so that means it has a horizontal asymptote. I mean, not a horizontal asymptote, a vertical asymptote. No horizontal asymptote. But let's not talk about that. I was talking about where it crosses. So on the y-axis, the y-intercept is at 0, -1. Cool. It does have a horizontal asymptote at -2, but we'll go ahead and prove it by pushing the trace button. So, yep, it gets closer and closer. Can you see that -1.999 for the y value right there? It's getting closer and closer to 2 without ever actually touching the 2 there. Okay? So that's what happens there. And so we are going to put a horizontal asymptote at -2, and then the graph will actually take off there. So there's our graph. This does still represent growth, even though it's down below. And if you want to check maybe where it crosses, it looks like actually maybe at a half there on the x-axis. But that one wasn't too bad. We just used our graphing calculator. Yeah, maybe about a half. Let's see. Okay, so growth, -2, and then it crosses maybe a little bit more narrow, but we're doing good there for number 8. And we do have the y-intercept at 0, -1. Make sure to label that y-intercept so we can make it easier for grading purposes. Okay, so last but not least, we'll see if we can do, number 13 and 15. Those look like tough ones there. So number 13, you can use an XY table, which would be fine. But even easier would probably be to just use your calculator, huh? So we'll put 0 for the to find the y-intercept. So we get -2 to the 0 minus 1, which 0 minus 1 is just -1. And so that actually becomes -1/2. So 0, -1/2 is where that y-intercept is. And so I'm going to go ahead and put in my calculator to make this even easier. So that's going to be, let's use parentheses just in case. So -2 to the x minus 1, there it is. Then we'll close, then we'll close parenthesis there. So it should be at about 1/2 is where that y-intercept is. Let's see, yep, right there at -1/2. It does go downwards, so negative growth, and it does have a y-intercept at 0. So you can put neither, or you can put negative growth. So you can see these are a lot faster with your graphing calculator. Definitely a lot faster there. Cool. So I'll let you try the rest of these on your own here. You got this. So thanks for watching, and I hope this video helped you. And so come see me if you need more help. You can see that number 16 will have a, just to help you, last one there, horizontal asymptote at -4, and double check it out and make sure we did that right. All right, thanks for watching. Peace out. Thanks for watching. Bye. Yeah, everyone say bye. Bye. Yeah.